Hey dude, what's up? Okay, so I've been doing a lot of thinking about this block thing and you know, and what and your objection to it, and just trying to think about what it is that we're saying that's different. Okay, and I made some pictures. Let's see. Uh-huh. Uh-huh. Ah. Oh, not that one. Yeah. Okay. Now we just got to agree on this. Now, okay, so you're, as far as I'm aware, just want to make sure that we both agree. Like, now it's the top part that I haven't heard you confirm yet, but okay. So I'm saying that these are there's a mesh, right? There's this little block here that's a mesh, okay, and this can be any size. Then what we do is we chain them together. Now for some reason I started to suspect that maybe you don't agree with me on that. That you start out by a long chain, and that the only difference between what we're talking about, like our initial approach and this new approach that I've put, is how it is that we bend this chain, right? And what we're doing at the moment is that, our initial approach is that we have this path defined by these points, and then we take this mesh chain and we just tell it to go along this path, right? Because you made a comment in your email saying that the path does not go through the center of the mesh. I'm not sure what you meant by that, or if I heard you correctly. Okay, but this is currently what we have, and you can imagine if you grab this chain, I was thinking that if we did this in the editor, that if you click on it and then you move the mouse left and right, this chain will displace along here. See, that's the one thing that we haven't defined, with just these two, is that even though if we have a mesh chain and a path, you have to decide on where this chain starts, right? And you can imagine what would happen if you pulled this all the way to the end and now this chain is halfway over. Well, it would just be flat. It would just go straight up, right? Just like the edge here. It would just go straight up and then bend just on these, this last little bit here will bend over here. And I think this is very cool. I think this is a very cool tool to have. Okay. I really like it. Okay, let's see what this is. Fucking blurry, man. I couldn't get this thing to focus. I don't know why. Okay, well, fuck, it's blurry. Hopefully you'll be able to see what this is. Okay, so the first thing I was like, okay, I just want to go through all the different permutations. Okay, what happens when, based on what I just described, if we delete one of the mesh blocks, if we add one, if we change one. Okay, so if you delete one, presumably all that happens is these two things are now no longer linked. And then you can click on this guy and you can pull him up and down, and then click on this one, pull him up and down. And if you bring these two together, they snap together or something like that, right? Whatever. Or we can make them snap together. If you add one, okay, then it just adds, and then it pushes this one to the left and this one to the right, right? If you add a block in here, and then it's still along this path, right? And if you change one, let's say we lengthen this, change this guy to a longer one, this thing lengthens, but it will still just be on the path, right? So, yeah. And we could have an anchoring concept as well. Like we could anchor one of these mesh blocks relative to the path. So you say, okay, this mesh block here must always be at this point, right? And the rest of these guys are free to move. So if you add, it's going to add to the end, right? If you anchor this one, it's going to add to the other end, you can imagine there's tons of stuff that we could do with this kind of mechanic. Okay, so that's what we've got currently, and now I've suggested this other thing. And what did I suggest? Okay, I suggest, fuck the path. We just have this mesh chain, and then what we do is we click here and we anchor this guy's position, and then we click here and we say, okay, we want to change this guy's rotation and then rotate it, and then this whole thing rotates, right? And it's forced to stay here and it rotates around, right? So instead of having a path that's just fixed in space and then applying the mesh to it, we then specify on the mesh where in space it must be, and its properties, like its rotation, the gradient of the rotation, the gradient of the position. Okay, so yeah, so now we're debating which one's better. What I've realized is that we really are just defining two possible sides to how you can control the curvature of this mesh, this chain. If you're okay with the term chain, if you're okay with the concept that it is a chain, at least in 1D. Okay, so yeah, so see if you agree with me on this. So the method 1 is saying the position of the chain in space. It's like method 1 actually draws a path in space. It almost bends space, and then you just kind of the mesh chain then has to go through that, right? Method 2 says, method 2 is like relative. I mean, it's bizarre. It's like you're in the second method, you're saying, you're not actually saying what the you actually directly specify the properties of the mesh. Like you specify the property of the like the position of the mesh, the rotation of the mesh. Like this block here, we can specify. You can say, okay, I want this block to be here, and I want it to stay there, and I want this block to be rotated like this, and then I want this block to be over here, and then all this stuff bends and does whatever it must in order to satisfy your constraints, right? So you have two different kinds of constraints. The one is the constraint on space in a way, and the other one is a constraint on the object. I'm starting to feel a bit hazy about it, but I had this epiphany, right? When I was doing my master's, I was doing it on fluid dynamics, right? And there was this thing called Lagrangian and Eulerian specifications, or derivatives, or gradients rather, in 3D, or more than one dimension, right? So it's a very interesting way of looking at things. So you've got a fluid, and you want to somehow specify the fluid itself. I don't know if you did any kind of fluid flow stuff, but there's two ways of looking at fluid flow, right? If you want to write a simulator or a solver of fluid equations, there's two ways you can do it. The one is you slice the space up into blocks, right? And then you have an equation for what happens in every single block, right? So you're literally breaking up the space in which the fluid exists into the static grid, and then you are then you have an equation for how it is that each block, what the density and the velocity of the fluid in each block is, and you try and solve that. The other way to do it is to take the fluid itself, right? You take the fluid as like this blob of liquid, and then you slice the blob of liquid into blocks, right? Or into a grid or whatever. And then you solve it in terms of the liquid. Like, and you see how both things are solving the same thing, but using like a different concept. It's kind of like yin and yang. It's just two ways of looking at it. Euler, this is not Euler by the way, it's Euler. Euler was the guy who said, okay, let's just slice space up into a grid, right? It's like the oldest thing. Geometry at first was all about slicing up space. Then Lagrange, I don't know why he got his name attached to this, but the Lagrangian idea is like, let's not slice up space, let's slice up the object, you know. And then because I mean, you can imagine with with the solid material, slicing up space and the object, I mean, there's no reason to slice up the object because the object doesn't change, right? But if the object itself is changing, is fluid, like completely fluid, can change, every part of it can change, all the variables throughout it can change, then the best way to slice up, then another interesting option is to slice the object up, right? And the reason I bring this up is because this is Eulerian. We're specifying the path, we're specifying the position, what the position must be relative, what a property must be relative to a fixed axis, relative to space, right? So you move this bad boy around and he has to snap, and we're fixing the properties fixed onto the spatial grid, onto space. Another way we could do it is we could fix the properties relative to this chain mesh, right? So no matter where the chain mesh is, we could still fix its properties. So one thing we could do is we could have this thing here, this fixed spatial thing here, and it is fixing a property of the mesh chain, right? Relative to the background, which is the spatial coordinates. And then the mesh chain itself, we could say, let's say we could take this last block and we could tell it to rotate, right? We just force this guy to rotate. And what we want is when we push this guy up and down, that rotation must stay the same, right? Right, so we push it up and this rotation stays the same, but now we've changed the property relative to the actual object itself. We could also change the rotation in a fixed point in space. So imagine if this mesh point here, if we said, okay, we want the rotation to be a certain amount at this point, right? Then what happens if we push this mesh chain along, it will stay flat, and then as it starts passing this point, all these mesh links will start to rotate. And if you keep pushing it, it'll be like a wave of rotation goes through this mesh chain, because we're saying anything that passes this point must have a certain rotation. So can you see what I'm trying to get at? I'm saying that we should have both, right? And that it's really interesting what we're actually doing. What we're doing is we're specifying properties, right? And there's two ways in which we can specify a property. We can specify a property in terms of space, or in terms of the. I gotta get some good words here. I mean, we could use Eulerian and Lagrangian, but fuck. You know, I mean, I guess that's a fancy way to do it, but this isn't really fluid mechanics. I don't know if they use it outside of the fluid mechanics industry. You know, we could use spatial, fixed or background spatial grid, like specification. Like you could specify a value in space, or you could specify a value in the substance itself. I've got to come up with like a word that we can use for this. I mean, this thing doesn't have anything except for Eulerian. And here's a frame of reference in any coordinate system. In general, both the Lagrangian specification of the fluid field can be applied in observer's frame of reference. Okay, Lagrangian and an Eulerian frame of reference. Plotting the position of an individual parcel through the time gives the path line of the parcel. This can be visualized as sitting in a boat and drifting down a river. Okay, this is generalized coordinates. Generalized Cartesian. I've got to come up with a word. You see what I mean? So, application of generalized coordinates. Okay, so where's some reference configuration? I mean, but you know what I'm saying. Like we're saying that either you can specify the properties in space, like anytime any of our shit goes past that spatial point, that will set the property of the thing that's passing that spatial point. Or we can set it like on the object itself, right? So we can tell the object itself it must have a certain property, right? So we can go to this fucking mesh point here, and we can say, okay, you must have X property. You must be in this position, you must have this rotation, you must have your position's derivative must be X, your position's rotation. And the fascinating thing about what I'm describing is, if we look at it like this, it doesn't just have to be geometry. Why not force, you know, the I don't know, temperature or viscosity or anything, any fucking property. You know, it'd be amazing if, you know, could you imagine? Let's say we put here a color, right? We put a color here, green. That means that if we take this guy and we move him along, all these mesh points will suddenly be highlighted as green, but only as they pass this point. You see what I mean? Like, it's a really fascinating kind of idea of two different ways of specifying properties, right? This path idea that we have is just specifying certain spatial properties that we want. But, you know, this path over here is specifying the gradient that this guy must have as it passes this point, right? And the position it has as it passes that point. But that's obvious, because what we're doing is we have a system, two different systems for calculating properties. The one is just which block are we looking at, and the other one says, okay, what position is the block look in? And then, okay, based on that, what property does this position, you know, give? So there's a function relative to position, and then there's a function, you know, relative to what block we're looking at, block number or whatever. Anyway, I mean, we could keep going and keep generalizing this. We can do some crazy shit, but I hope. Yeah, I hope this is making sense. You know, what I want, I mean, what I'd like to do is to, I don't know, keep going, see how interesting we can get, but right now I'm suggesting that we have both. You know, we have this thing where we can just tell it to snap to a path, and then if we can just set the properties of each one if we want as well. We can fix the positions if we want, we can fix the rotations, and we can do it in terms of the actual mesh objects itself, and we can turn that off, turn it on, or we can, you know, use just that, we can use just the path, we can do everything, right? I mean, it's a fascinating way of looking at it. Yeah. If this stuff is making more sense to you, you know, if this stuff makes sense to you and you agree, you like it, you know, then I'd dig to hash this out and go even deeper with this whole properties idea, you know, like specifying properties. Like you could have, you know, like what I'm saying, what we're doing now is we have a property here, like you have a rotation here and a rotation here, and that will cause this long kind of, will interpolate between the two and cause this long rotation between the two. But why not have, like, I don't know, it's an interesting idea. I mean, maybe we wouldn't need to use it, like maybe it's just a silly thing to say that you would have, like, I don't know, like height, you know, or I don't know, like brightness, or any fucking property, like trees, you know, like we could specify in space how many trees there are, and we could specify on the actual mesh chain how many trees there are. So the properties are actually abstracted away, right? So you know, there's a property solver that we put in. So at every point, it has to solve what properties are going to be there, like for each guy. So we can actually abstract out this geometric thing, you know, and have like properties, just generic properties, and you could specify the properties in terms of a fixed spatial coordinates, or you can specify the properties in terms of the actual mesh blocks themselves, you know, and then what it does is in this chain it interpolates them, and then it also interpolates between the fixed spatial coordinates of whatever the properties are. I hope that sounds good. Let me know.